Welcome to our deep dive today. Straight to the cutting edge we go, diving into rxorv.org, where researchers share their newest findings, all hot off the press. Ready for a rapid-fire look at the most interesting AI developments of the day.
It's a sneak peek at the future of AI, really. We get to see what's bubbling up before it hits the mainstream.
We'll start with algorithms that use machine learning predictions. Researchers are making them even smarter, but the thing is, not every prediction is as good as the next.
And that's where calibration comes in. Think of each prediction having like a trustworthiness score. Helps the algorithms cut through the noise and zero in on those really reliable signals.
So instead of just blindly following every prediction, now algorithms can actually pick the ones with, the highest confidence levels, the ones they're more sure about.
Exactly. And this could be a game changer for making decisions in real time, especially in areas like resource allocation or scheduling where efficiency is everything. Think about optimizing delivery routes on the fly based on up-to-the-minute traffic predictions, or financial institutions predicting loan defaults with, a much higher degree of accuracy.
This calibration idea, it kind of reminds me of another trend we're seeing, figuring out uncertainty in neural networks.
Right. Deep learning models are powerful, no doubt, but knowing how sure they are about their predictions, that's critical, especially in things like healthcare or autonomous driving where the stakes are high.
It's like the difference between a doctor saying, you might have this condition versus we're 95% sure you have this. That level of certainty changes how you approach things.
Absolutely. And they're developing new ways to figure out this uncertainty more effectively. One way uses the empirical neural tangent kernel. It basically gives you a range of possible predictions instead of just one definitive answer.
So instead of just saying, this is a cat, the network might say, I'm 80% sure this is a cat, but there's a 20% chance it's a rabbit.
Exactly. Having that range is super important for making AI more transparent and trustworthy, especially in those really important scenarios. It acknowledges that there is uncertainty in complex systems.
Okay, let's shift gears to anomaly detection and time series data. This is vital for everything from tracking the stock market to predicting equipment failures. What's new on this front?
Well, researchers are developing some really sophisticated techniques to analyze data over time. One method involves looking for statistically significant changes across multiple frequencies in the data. This gives us a more detailed understanding of the underlying patterns, helps us tell the difference between real structural shifts from just random noise.
So it's like analyzing the rhythm of a heartbeat, trying to find those subtle irregularities that might point to a problem. This approach could be a game changer for preventative maintenance across industries.
Absolutely. If you can catch those little warning signs early on, you can head off major problems, keep things running smoothly.
Now let's talk about diffusion models. They've revolutionized image generation, but researchers are finding ways to make them even more powerful.
Oh yeah, they're finding clever ways to guide these models, give them more control, more flexibility. One method uses a mixture-based approach, allows for more precise control over the output. Imagine being able to tell the model exactly what kind of image you want, like a super detailed creative brief, and it just nails it, like an AI artist that follows your directions to a T.
That level of control, the possibilities for the creative industries are huge. We could see a surge in personalized content creation tailored to exactly what each person wants. What other cool things are happening in AI optimization?
We're seeing tons of applications, from designing super tiny structures and metamaterials, which could lead to crazy breakthroughs in fields like optics and acoustics, all the way to managing traffic flow in real time to make our cities less congested.
AI is like the ultimate problem solver, tackling challenges big and small.
And one of the most exciting areas is zero-shot learning. It's where AI models can do tasks they've never even been trained for. This is a big step towards creating truly adaptable AI systems, the kind that can quickly learn and adapt to brand new situations.
Sounds like having an AI apprentice, the kind that picks up new skills just by watching. What are some examples of this zero-shot learning in action?
There are new models that can segment objects in a robotic environment, take a basic map and enhance it with information from road manuals, even generate really complex visual reasoning constructions. Picture a robot that can figure out how to put together a piece of furniture just from the instruction manual. No training needed.
That's wild. It sounds like we're getting closer to AI that can learn and think like humans.
We are, but while we're all excited about these breakthroughs, we have to remember that data-driven approaches do have their limitations. Researchers are looking into those limitations and figuring out ways to address them.
So it's all about pushing AI to its limits, but also being aware of where those limits are. What are some specific limitations that researchers are tackling?
Well, one study highlights the difficulty of recreating spectral information from just RGB images. It points out the need for more robust approaches that factor in how light actually works. This is especially important in fields like medical imaging, where accuracy is paramount.
Seems like every breakthrough brings new challenges, pushes researchers to think harder about how complex AI really is. Now let's talk about the giants in the room, large language models, or LLMs.
These models are constantly being pushed to new heights. They're handling increasingly complex tasks, things like predicting outcomes of legal cases, summarizing meetings, even generating synthetic data to train other AI models. The sheer versatility of these models is amazing.
It's like they're becoming the Swiss Army knives of the AI world. What are some of the biggest recent developments with LLMs?
We're seeing improvements in how they handle factual information, which is huge if we want to make sure their output is reliable and trustworthy. And researchers are working on ways to improve the decoding process, making it easier to extract accurate, meaningful information from all the data these models generate.
So it's not just about making LLMs bigger and more powerful, it's also about making them more accurate and trustworthy.
Exactly. As these models become more integrated into our lives, we have to make sure we can trust them, which leads us to the ethical considerations surrounding LLMs. These are becoming increasingly important as these models get more powerful.
It's crucial to make sure these tools are used responsibly, that they benefit society. What kind of work is being done to address these ethical concerns?
Researchers are developing new benchmarks to evaluate how safe LLMs are, taking into account the context they're being used in. That means going beyond just how accurate their output is. They're looking at the potential impact of their responses in real-world situations.
So it's not just what the LLM says, it's about how it's used and what the consequences could be.
Exactly. Context is key when it comes to figuring out the ethical implications of these powerful tools.
Wow, we've covered a lot of ground in the world of AI research. We'll be back in a flash with even more cutting-edge news. Back again with our deep dive into the latest AI research.
We're seeing some really groundbreaking stuff happening in autonomous driving.
Yeah, self-driving cars have been a hot topic for what seems like forever. But this new research, it suggests we're getting closer than ever to really reliable autonomy.
One study shows how powerful it is to train a self-driving car policy entirely in a simulated environment. We're talking about simulating like a massive scale, 1.6 billion kilometers of driving.
Wow, that's mind-boggling. But can a car that's only ever driven in a virtual world really handle the messiness of real roads?
That's the amazing part. This policy, trained only in simulation, it actually did better than systems trained on real-world data, and it did it without using any human driving data during training.
So it's like a self-taught driver. It learns just by trying and failing in this virtual world.
Exactly. And the results are impressive. In simulation, this policy averages a crazy 17.5 years of continuous driving before anything goes wrong. That's a level of robustness we haven't seen before.
It does seem like a big jump forward for the reliability and safety of self-driving systems.
It really shows the power of simulation and self-play for developing really intelligent systems.
Let's switch gears for a second and talk about transformers. These models have changed natural language processing, but now researchers are looking at what they can do with time series data.
Yeah, time series data, that's anything collected over time, like stock prices, weather patterns, even your heart rate. Transformers are showing they can really understand and predict these complex patterns.
So could we use them to forecast the stock market or predict earthquakes?
Well, researchers are showing that transformers are great at automatically fitting those autoregressive models that are often used for time series forecasting.
So they can figure out the patterns and relationships in the data, then use that to make predictions about what's going to happen next.
And they can handle more than just one variable. There's a model called MoIRA, for instance. It can deal with tons of factors that might affect the time series, so it can make more comprehensive and accurate predictions.
That opens up some exciting possibilities for finance, meteorology, even healthcare, all fields where predicting future trends is crucial.
But like with any powerful technology, we have to think about the ethical implications. We're seeing a growing emphasis on making sure large language models, or LLMs, are used safely and responsibly.
LLMs like ChatGPT, they become incredibly popular. But there's always a chance they could be used for the wrong reasons.
Definitely. Researchers are developing new benchmarks to evaluate the safety of these models, really considering the context they're being used in. It's not just about what they say, but the circumstances surrounding what they say.
It seems like context is a big deal in AI development. It's about understanding not just what these models can do, but also what might happen as a result of what they do.
One key area of focus is figuring out how to detect and prevent deception in LLMs.
Deception. You mean like the LLM is trying to trick us or hide its true intentions?
Well, as LLMs become more sophisticated, there's a worry that they could learn deceptive strategies, especially if their goals aren't the same as ours.
Sounds a little bit like science fiction, but I guess it makes sense given how fast AI is developing.
Right. Researchers are coming up with ways to catch this deception. One approach is to use these things called linear probes to watch what's happening inside the LLM.
So we're going beyond just looking at the output and actually peeking inside to see if it's trying to pull something sneaky.
Exactly. These probes are trained to tell the difference between honest and deceptive responses based on the activity patterns inside the model. And the early results are promising. They're showing high accuracy in detecting deception.
That feels like a really important step for building trust in these increasingly powerful AI systems.
Yeah, it's a constant challenge, especially as LLMs keep evolving. But researchers are committed to figuring out ways to ensure they're being used safely and ethically.
Now, what about data distillation? It's a technique for making data sets smaller and easier to manage while keeping all the important stuff for training AI models.
Think of it like creating a super concentrated version of the data. It's really important for those sequential recommendation systems, the ones that predict what you might want to watch, buy, or listen to next based on what you've done before.
Those systems rely on tons of data about what people like, which can be really computationally expensive to deal with.
And that's where data distillation comes in. There's a new method called TD3, stands for Tucker Decomposition-Based Dataset Distillation. It's showing a lot of promise.
How does TD3 work? Does it just randomly throw away data points until the data set is small enough?
It's more clever than that. TD3 uses Tucker decomposition to pull out the most important underlying patterns from the data. Then it uses those patterns to create a smaller synthetic data set.
So it's not just about making the data set smaller, it's about figuring out and keeping the most valuable information.
Right, and the results are really good. TD3 can shrink the data set quite a bit while still maintaining or even improving how well the recommendation system works.
So we can train models faster and more efficiently without sacrificing accuracy. That's a win-win.
Absolutely. Now let's shift our focus to materials design. AI is becoming a big player in this field, helping us discover and develop new materials with very specific properties much faster.
Materials science is all about creating materials with the characteristics we want, like stronger alloys, more efficient solar panels, or polymers that can heal themselves. But traditionally, it's been a slow and tedious process.
AI is changing that. We can now explore huge design spaces and predict what properties new materials will have much faster and more accurately.
So instead of spending years in the lab mixing and testing different combinations, we can use AI to point us in the right direction.
One particularly exciting area is inverse design. Here, we start with the properties we want and use AI to create a design that meets those specific requirements.
It's like having an AI materials chef who can whip up the perfect recipe for any material you can dream up.
It's pretty amazing. AI is being used to design lighter and stronger aerospace materials, more efficient catalysts for chemical reactions, and tons more.
It's really cool how AI is transforming such a fundamental area of science.
And as AI keeps advancing, we can expect even more breakthroughs in materials design in the years to come.
And we're back for the final part of our AI News Roundup. We've covered a lot of ground, from algorithms that get uncertainty to AI designing new materials. But now we're stepping into a world where quantum mechanics and machine learning collide.
That's right. We're talking about the incredible potential of quantum computing for AI.
Quantum computing is known for its ability to solve problems that are way beyond even the most powerful classical computers. So how is this power being used for AI?
Well, researchers are looking into quantum algorithms for things like data set balancing. That's really important for training AI models that are fair and accurate. Imagine a quantum algorithm that can perfectly balance a data set in just milliseconds. Talk about speed and efficiency.
That would be a game changer for fields like medical diagnosis or fraud detection, where imbalanced data sets can lead to biased and inaccurate predictions.
Absolutely. Quantum computing is still in its early stages, but the potential to transform how we train and use AI is huge.
And speaking of transformative applications, AI is now being used to analyze not just words and images, but emotions as well.
This is the fascinating field of multimodal sentiment analysis. It combines information from different sources, like text and images, to understand the emotional tone of a message.
So it's not just about what someone says, but how they say it and the visual cues they use.
Exactly. New models, like LVAC, which is fine-tuned from the large language and vision assistant model, are showing really impressive results in multimodal sentiment analysis.
This could be really important for social media monitoring, where understanding the emotional context of online conversations is so crucial.
Imagine being able to accurately gauge the sentiment behind a tweet that includes both text and an image. Multimodal sentiment analysis can offer that level of nuance.
For our last topic today, let's turn to a challenge that's becoming more and more important: managing the electric grid as more and more people switch to electric vehicles.
Yeah, it's a complex problem that requires balancing supply and demand in real time. AI is becoming a key tool for optimizing how electric vehicles are charged.
So instead of just plugging in your car when you get home, AI could figure out the best time to charge based on things like electricity prices, how much capacity the grid has, and even your driving habits.
Exactly. One study shows how a combination of large language models and graph neural networks can be used to optimize EV charging. It takes all those complex variables into account.
That could help prevent blackouts, lower energy costs, and make the transition to electric vehicles smoother. It's a perfect example of how AI can tackle real-world challenges.
And as we've seen today, the world of AI is constantly evolving, tackling everything from the fundamental laws of physics to the complexities of human emotion.
It's a really exciting time to be following this field. Who knows what breakthroughs are just around the corner?
Until our next deep dive, keep exploring, stay curious, and never stop wondering about what AI can do.